Alrighty, welcome back to lesson 7-4, which is scale drawings or scale factor. So it does say here, scale drawings or scale models, so you can use either way, are used to represent objects that are too large or too small to be drawn or built at actual size. So this would mean a lot of things that you would see is like a model car or a model airplane. A lot of times you see them on maps, which is what we're going to work with today. So there's a lot of different things that have either scale drawings or scale models. Another thing would be like a blueprint of a house. You're not going to actually draw out the full scale of a house. You're going to make a blueprint of it, so you're not making these big measurements. So it says the scale gives the ratio or fraction, because remember a ratio can be written as a fraction, that compares the measurement of the drawing or model to the measurement of the real object. That's important to note. So it's comparing the drawing or model to the measurement of the real. So drawing or model to the actual real. So that's the fraction. So it's model over actual. So it says the measurements on a drawing or model are proportional to the measurements on the actual object. So if you're looking at the window on a model car, that window is going to be exactly proportional to the window on the actual car. So it says below is an example of a scale drawing. What is the actual distance of D between Miami and Key West? So ideally, what we would have done if we were in school is we would have actually mapped out and used a ruler to trace from Miami to Key West to see exactly how far it is. Okay, but I'm just going to give you those today so that in case you don't have a ruler at home. So at the bottom of our map here of Florida, you can see where I'm boxing here in red. That is actually going to be our scale of our map. So that's saying that for every 0.5 inches that we draw on our map, it's 50 miles in real life. So that's how you could determine how far something is from one another. So it says step 1, locate the scale on the map. So that would be 0.5 inches on our map to our actual of 50 miles. Okay. So step 2 says, using a ruler, measure the distance between Miami and Key West. So this is where I'm going to give this to you. So ideally what you would have done is you would have actually measured the distance from Miami to Key West. But I'm going to give that to you today, and that's going to be 1.5 inches. Okay. So for step 3, it says use the scale to write and solve a proportion. So our scale is our first step that we actually did. So this part here, and we're going to put that into our scale. So we have 0.5 inches is our map, and our actual is 50 miles. So where it says actual measurements, on the top it's still going to contain your map actual measurements. So what we actually measured from Miami to Key West. So that would be 1.5 inches. And then since we don't know the actual yet, that's just going to be X. So X miles. Okay, so from here we are going to use our cross multiplication to actually solve and simplify. So I'm going to go ahead and rewrite this as 0.5 over 50 is equal to 1.5 over X. So just like before, we learned this before where we are going to cross multiply. So this is going to be 0.5 times X is equal to 50 times 1.5. Okay, so if we have 0.5 times X, that's actually going to give us 0.5X. And 50 times 1.5 is going to give us 75. Then this is a one-step equation. We're just going to divide by 0.5 on both sides. So that would mean X would equal 150 miles. So what it's saying is that in real life, to get from Miami to Key West, you would drive 150 miles. Okay, go ahead and flip onto the back. All right, so our formula to find a missing measurement. So our scale is our map over our actual, and the actual length is on the map, so what you measured over the actual, which is real life, what's actually measured. So this is just going to be A over B. So on the map over actual, and then on the map over actual, so C over D. They're all different because they're all going to be different numbers. Okay, so for example number 1, it says a scooter is 42 inches long. Find the length of a scale model, so that's what we're looking for, of the scooter if the scale is 1 inch is equal to 9 inches. So our scale is given to us. That is going to be our first fraction. So we have 1 inch over 9 inches. Okay, and remember the top is what you need to measure, okay, over the actual. So we aren't told what the scale model, the length is of the scooter. So that's going to be our x, and then that's going to be over 42 inches because we are told that the scooter is actually 42 inches. Okay, so then we're going to do exactly what we did in the last problem. We are going to rewrite it and cross multiply to solve. Okay, so we have 1 times 42 is equal to 9 times x. So this is going to be 42 is equal to 9x. And we're going to go ahead and divide by 9. And my x is going to equal 4.6 inches. What that means is the scale of the scooter, so the length of the scooter on the scale model is 4.6 inches. Now it might ask you in another problem what the scale factor is. So our scale factor is what is the actual scale in simplest terms. So that would be 1 over 9. Okay. All right. Example 2. It says, a blueprint of a house shows for every 0.5 inches on a map, it represents 36 inches of the actual home. So 0.5 on a map represents 36 inches of the home. What is the actual length of the bedroom? That is 2 inches on the blueprint. So we are given our scale, which was 0.5 inches over 36 inches. And then we are looking for the actual length of the bedroom. So that's going to be our denominator. And our measurement on our picture or our blueprint of our house is 2 inches. So that's our top. Okay, so just like the other problems, we are going to rewrite it and solve. So I have 0.5 over 36 is equal to 2 over x. Cross multiply to solve. So I would have 0.5 times x is equal to 36 times 2. So 0.5x is equal to 72. Divide by 0.5. So we would have x is equal to 144 inches. So that means that in real life, the actual length of the bedroom would be 144 inches. Okay, so part B of this was what is the scale factor? So we're going to start with our scale of 0.5 inches over 36. So we have 0.5 inches over 36 inches. However, the top number here needs to be 1. It can't be a decimal, it has to be a whole number. So how do we get from 0.5 to 1? Well, we're going to multiply both of them by 2. Because when we multiply 0.5 times 2, we get 1. So this would equal 1 inch over 72 inches. So this would be our scale factor. So that means for every 1 inch on the blueprint of the house would equal 72 inches in real life. All right, in our last example, it says, what is the scale factor of a model car if the scale is 2 inch is equal to 3 feet? So this one is interesting because we have inches in the numerator and feet in the denominator. So with scale factor, the one thing you have to do is convert all to the same units. So the easiest way for us to do this would be to convert the feet into inches. So I'm going to say convert to inches. Okay, so if you're unsure, we know that 12 inches is equal to 1 foot. So if we're looking for the total number of inches, how I could set this up is 12 inches over 1 foot is equal to x over 4 feet. The other thing you could just do is 12 times 4. So that would mean that 4 feet would equal 48 inches. Okay? So because we are going to convert it and make it into a scale factor, we are going to rewrite this. So we have 2 inches over 48 inches because we just changed our feet into inches. And we want our top number to equal 1. So we're going to divide by 2 on the top and the bottom. And we get 1 inch is equal to 24 inches in real life. So that would be our scale factor. Okay, please go ahead and complete the 7-4 homework for today. Thanks for watching.